Hello, my name is Johnny Bannon. I will be your CCNA instructor for this CCNA video series. In this video, this is going to be part 3 of QoS, if you include that intro video, where now we're going to go over the different QoS models. So we just went over the overview and the why of QoS. If you didn't watch that video, please go watch it because these kind of build on top of each other, right? So now the QoS models. So this is another high-level overview of how network architecture from end to end through an ISP over the internet, the different QoS models that Cisco describes, and kind of just the industry standard, right? So there's 3. There's best effort. Actually, let me go back a slide. There's best effort. There's integrated services, and then diffserv. Diffserv is the one we focus on, the one that when we implement QoS, we're implementing a diffserv architecture or topology across our enterprise. Best effort is considered a QoS model, but not really, and this will make sense in the next slide. Then integrated services is going to be application-based and using the resource reservation protocol. I don't really know much about intserv. I've only had to read about it, never actually applied it or done anything with it. So when we get to that slide, I'm just going to go over it, what the slide says, the bullet points, and then what we'll deep dive into is the diffserv, because that's where we are. That's what we're configuring for QoS. We're setting up a differentiated services topology where we classify our traffic. Where we have integrated services, the applications using the resource reservation protocol are going to signal to each other that they need some quality of service. I honestly I couldn't tell you a deep dive on how it works or the complexities of it, because again, I focused on learning diffserv for this, because that's what the CCNA exam wants you to learn. So with that being said, let's just go ahead and go over the models. QoS best effort. So this technically, it's labeled as a QoS model, but what this means is that there is no QoS policy applied. So this best effort means that there is no QoS. We're just doing first in, first out queuing, and it's just best effort. So we have a router here connected to an ISP. We have our LAN, right? All of our routers, or all of our switches on computers, endpoints, and we're just sending traffic. We don't have any way to do any manipulation of this traffic, to classify it, to queue it a certain way, to prioritize, shape, or police. It's just best effort. It's when you set up a network and you get it configured, you get it up and running, boom, and you bounce. And that's QoS model best effort. So let's go to our next one, integrated services. So this is the QoS model. I was telling you that, not really too sure, how it works. But essentially, an application is going to request a specific service from the network before sending data. So we have nodes here, or these end devices that are saying, hey, I'm QoS aware, and I want to request a SSH session. But before I do it, I want you to, using the RSVP protocol, to send to my other QoS aware node and tell them, hey, we're going to do an SSH connection to each other, and I want a traffic profile applied to me. And the whole network will understand that, and it's going to give that end-to-end path and that quality of service for that application, whatever it may be. In this example, I said SSH, but it could be anything. So this does involve QoS-aware endpoints, which typically you don't see. If my computer sends HTTP traffic when it builds that IP header, it's not putting any classification or marking bits in that header. It's just sending, right? So it's a little different. Now going into the model that we're going to deep dive into, the differentiated services model, or diffserv. So this is where we as network engineers and administrators look at our enterprise, look at our topologies, and now we're going to classify traffic based on our business requirements in case there's congestion on the network. So we're going to create classes of traffic with markings, and then we're going to decide what level of service we want to give this classified traffic, what queues they're going to go into, how we're going to shape that traffic, how we're going to police it, what is the dedicated bandwidth we may give it, is it going to be priority? And then as these packets traverse a network, each network device should identify this class and give it the same QoS level of service. As we were talking about before, though, there's trust boundaries that we need to worry about. So in a perfect world, this differentiated services model, every router in this, what they call IP backbone, but essentially ISP, or however you're getting to your entire enterprise, HQ to spoke, they are all aware of the classifications and the policies, and they're going to apply the same policies in a complete diff-serve topology. Now, again, when do we see this? We hardly ever do. But when we start building our tunnels and our point-to-point connections through an IP backbone, or let's say we configure MPLS, which label switches us and gives us the appearance of a direct connection between customer edge and customer edge router in our enterprise, QoS can still be used, even if these routers aren't. So really, your WAN architectures are going to have a big play into QoS and whether or not that our marking classifications and our policies are going to be applied enterprise-wide. So with that differentiated services model, sometimes it can be all for naught, especially if you're kind of doing like a split tunnel architecture where maybe regular internet traffic gets sent to the ISP to get routed. Well, that traffic's not going to do QoS, right? Because the ISP has to agree to it. And if they don't, then they don't. They could even add new markings or replace the markings that we put on. So understanding your architecture is a very important piece of QoS. And as I learned from some of my favorite instructors on YouTube, sometimes I gloss over this. Prepping for the exam, yes, I don't need to talk to you about how you need to be kind of aware in your planning of QoS, but it is important because QoS, one size does not fit all. So now that we've gone over these QoS models, let's go ahead and get into classification and marking. So classification and marking is very important. And we're going to go through all these slides, and I want it to be its own video. So what I'm going to do right now is just go over this quick little slide. And then in the next video, I'm going to start getting into actually how we mark. So classification and marking, this is where we actually start to group that IP-based traffic. And we have to mark it so that we can then set queuing and priorities on it. So that being said, let me go ahead and stop this video. And then hopefully we can do classifications and markings in one video, maybe under 30 minutes. So stay tuned.